Good day and welcome to Financial Mathematics. This module covers some basic literacy skills, and I will be going through three learning units, which includes Introduction to Business Calculations, working with non-integers, percentages, fractions, and proportions, working with equations, how to measure, analyze, communicate workplace data, as well as using mathematics to make financial decisions. So welcome to Learning Unit 1. This covers the pages 101 to 38. Just a quick overview of Chapter 1. Chapter 1 will start off with our number system, basic calculations involving positive numbers, as well as basic calculations involving negative numbers. The second video will cover Theme 2, which is order of operations, commutative, associative and distributive laws. And then the third video in this chapter will cover averages, exponents, and roots. So let's start off with the first theme, our number system. This is on page 1 to 22. The learning units covered includes executing algorithms appropriately in calculations, finding and recording measurements, differentiate between estimate and approximation, and explaining when one convention should be used as opposed to another. We use numbers every day. It is a part of everyday life. It includes everything from counting our change at a till point to calculating and generating a budget, a household budget, but also as part of our business and our work life every single day. Numeracy skills are important. It is a life skill, but also it's important in our work life to be able to communicate information as well as make sure that we can measure things. So our number system is made out of defined symbols, numbers, and rules, and it's based on the old Hindu Arabic system, which is based on the numbers 0 through to 10, and all numbers would include those 10 numbers. So what does that mean? If we turn to page 2, you look at a concept called place values. It's a position or place of a digit within a number determines the value it represents. Place value is central to our number system, and there is no value for. There's no value for 0. Review question 1.1 on page 5. Whole numbers. Numbers 1, 2, 3, and so forth is what we call whole numbers. It is divisible by 2. It's called even numbers, and these include things like 2, 4, 6, 8. And when it's not divisible by 2, it is called odd numbers, 3, 5, 7, and so forth. Negative numbers indicate losses or deficits. Numbers need to extend below 0. So if we look at our number line, it starts off with 0, and all the numbers to the right would then be called 1, 2, 3, and then everything extending to the left would then be 1, -1, -2, -3. So let's talk about a concept called integers. Integers can be written without a fractional or decimal component. 1, 2, 3, -1, -2. These are called integers, and we have positive integers and negative integers. And this is our generally accepted number line. So all of our positive integers extend through to infinity onto the right and to infinity to. There's a couple of important things that needs to be understood. In terms of integers, the notation A is smaller than B, this simply means that A is less than B. Also the notation A is bigger than B, and then also A is not equal to B, and then the notation A is less than or equal to B, or equal and less than, or A is bigger or less than B. Can use integers to compare with one another using the number line. You can also have a look at example 1.2 on page number 7. Important concept is fractions, and fractions are the numbers in between your integers. If we look at the numbers in between 2 and 3, it consists of, if we look at, it starts off with 2 and ends off with 3, and there are all of these fractions in between. So if we look 2.5, 2.9 over the side, 2.1, these are what we call fractions. And you can even express it as decimal fractions as well, which it starts off with 2, ends off with 3, and then you have 2 1/10, 2 2/10, and so forth. So you can express it as a decimal fraction, or you can express it as a normal fraction. So just to repeat, fractions are parts of numbers that can be expressed. And if you look at page 8, there are different types of fraction, which includes common fractions, decimal fractions, proper fractions, improper fractions, mixed numbers, recurring fractions as well, terminating decimal fractions, equivalent fractions, and also simplified fractions as well. Get to rational numbers. Rational numbers can be written in the form of a fraction, where a and b are both integers or whole numbers, and b is not a zero. So this would include, an example of this could be something like a over b, where both a and b are integers. Before we move on to the definition of an irrational number, a quick distinction between estimation and approximation. So what is estimation? Estimation is the mental skill of making an educated guess. It is an approximation that has been decided upon through making a judgment rather than by counting, measuring, or calculating. So we can say you may estimate the number of supporters attending a soccer match at 20,000, only to find out later that the head count was actually 23,423. Estimation is an important thing that we tend to use in order to make sense of large numbers. Approximation is where we round numbers. In mathematics, it's not the same thing as estimation. An approximation is also close to the true value of that number. However, with approximation, the true value is always known first. So for instance, if you go to the shop, which is quite an interesting one, so we tend to approximate prices at the shop. So something would be R1.99, so it's a known value. You would then simply say the product costs R2, because saying R2 is a lot easier than having to say it's R1 or it's R199. You'll just say it is easier to just say it's R200. So that's an approximation. It needs to be realistic and logical. The rounding of numbers in calculations When we suppose the population of a country stated as 56 million, which is approximately South Africa's population, it is quite possible that this figure has been rounded to the nearest million. We would therefore say that the country's population is 56 million, or so 56 million, and that's how it's expressed, and 56 million. So we would say, so the number would then be expressed, it's plus minus 56 million people, which is an estimate of the population. There are extreme cases whereby the units of a measurement are so small that they cannot be seen by the naked eye. A good example is a measurement of a virus under a microscope, and they will be looking at the smallest microscope, the micromillimeter. The rounding of numbers in calculations are also done. It's important only to round off numbers in the last stage of a calculation. They could contain various decimal points should one of the fact itself. It could have a significant impact on the final result. So when we look at rounding off numbers, when you get to a number and the final number is 56.676789 and you want to reduce that number and round it down to its final result, you would then round up. So you can round it to 56, to 57, because every number above greater than 0.45 gets rounded up, and less than 0.5 gets rounded down. So in this case you can be 57, or if you want to be a bit more accurate, you can also say 56.7, because we're rounding the 6 up to the closest 10, and then the 6 becomes a 7. So 56.7. Calculations involving positive numbers include things like addition. As you know, addition is simply just adding 1 plus 1 equals 2, or 102 plus 102 equals 204. And these are simple calculations, and they can be done with integers. And then you can also have subtraction, as you know, which is simply just taking a number. It's 2 minus 2 equals 0, or 2 minus 1 equals 1. Multiplication, a number done a simple one, and these are the things that you can still remember from school. 3 times 1 equals 3. And then division, which is 4 divided by 2, in which you have a denominator and a numerator equals 2. So these are the things that you can do with positive numbers and the basic calculations that it includes. So do basic calculations involving negative numbers. So let's see, for instance, when we measure temperature, we look at negative numbers, or we look at below Celsius. And an example of that would be, say for instance, you look at minus 4 Celsius, or so if it's 0 degrees and you look at minus 4, then it is minus 4 on that side. Or alternatively, if you want to add a negative number together, say it's minus 4 plus 5 equals 1. So what does that look like? It is minus 4 plus 5. So we go 5 spaces, 1, 2, 3, 4, 5, and that's the result. Of negative numbers as well, it works inverse as addition, and you can have a look. So it'd be something like something simple, like a minus 602 minus 71, and that would give you a result. Have a look at question series 1.10 on page 20 in order to have a look. Multiplication, a quick way of adding many additions of the same number, and this includes multiplication of negative numbers. So the basic rules apply. And there are a set of rules that apply to multiplying negative numbers together. For instance, when you add a positive times a positive, it will equal a positive. When you add a negative to a negative, it equals a positive. So every time you add a positive integer and you times it by a positive integer, it's a positive. Every time you add a negative integer and you times it with a negative integer, the answer is a positive. When you have a minus times a positive, it equals negative, or a positive times a negative equals a negative. So every time it's the same, it is positive. Every time they are different, it is negative. The answer would be a negative integer. Division, the same general rules apply to division. The quotient of a positive number and a negative number is a negative number, and the quotient of a negative number or two positive numbers is a positive number. A quotient is the answer when one number is divided by another. So it is 2 divided by 1 equals 2, or 4 divided by 2 equals 2, and that we call the quotient. For instance, minus 15 divided by 5 can also be expressed as minus 15 divided by 5 equals minus 3. 15 divided by minus 5 is minus 3. And then you have 15, which is a positive, divided by, sorry, in this case it's negative, divided by negative 15, and that gives you a 3. Now we come to something quite interesting, which is rules of negative numbers. Rules of negative numbers, as I said earlier, in terms of addition, when you add a plus and a plus, a positive integer and a positive integer, your answer is a positive. When you add a negative integer and a negative integer, your answer is negative. When you add a positive and a negative, it is a positive, and a positive and a negative, it's a negative. And then multiplication and addition, when the integers are the same, it's always a positive, and when they are different, it is always a negative. And that concludes the first theme, which is very basic calculations in understanding positive and negative integers, understanding multiplication, division, and subtraction and addition.